My dear students, welcome back to our channel. In this video, I will be explaining the BCA 5th semester subject Object-Oriented System Development as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 2 first important short question is: what is swim lane in activity diagram? A swim lane in an activity diagram is a visual way to show who does what in a process. It divides the diagram into lanes, horizontal or vertical sections, with each lane representing a person, role, or department responsible for certain activities. Think of it like a swimming pool with lanes. Each swimmer stays in their lane, just like each actor stays in their swim lane in a process. Simple meaning: swim lanes make it clear which actor or department performs which activity, avoiding confusion in complex processes. Example: imagine an online shopping system. Customer lane: browse product, add to cart. Payment lane: make payment. Delivery lane: ship product, deliver product. By using swim lanes, we can see who is responsible for each action and how activities flow from one role to another. Why swim lanes are useful? Makes responsibilities clear. Shows flow of control between roles. Helps in process analysis and improvement. Easy to communicate with team members. Easy trick to remember. Swim lane is equal to lanes in a swimming pool, lanes for actors in a process. It visually separates roles and their activities in the diagram, making complex processes easy to understand. Next important short question is: 2. What is the purpose of activity diagram? An activity diagram in object-oriented system development is used to show the flow of activities in a system or process. It is like a flowchart, but specially designed for modeling dynamic behavior of software systems. Purpose of activity diagram: 1. Visualize the workflow, shows the steps in a process clearly. 2. Understand system behavior, helps see how activities are connected and the order of execution. 3. Identify responsibilities, shows who performs which action with swim lanes. 4. Analyze processes, helps find bottlenecks or redundant steps. 5. Communicate with team, easy for developers, testers, and clients to understand. Example: consider an online shopping system. Customer adds items to cart. Makes payment. System processes order. Product is shipped. Delivery is completed. An activity diagram will show all these steps with arrows indicating the flow and decision points like payment success or failure. Easy trick to remember. Activity diagram is equal to step-by-step map of the process. It's used to visualize, understand, and communicate how a system works from start to finish. Next important short question is: 3. What is process? When it is used? In object-oriented system development, a process is a running instance of a program that performs specific tasks in the system. It represents a unit of work that the system can execute independently or along with other processes. Simple meaning: a process is like a worker in a factory. Each worker, process, performs its job, and multiple workers can work together to complete the overall task. When a process is used: 1. Concurrent tasks, when multiple activities need to run at the same time. 2. Long-running operations, tasks like printing, payment processing, or file downloading. 3. Isolation, when a task should run independently without affecting others. Example: in an online shopping system, order processing process handles order confirmation. Payment process handles payment transactions. Delivery process manages shipment. Each process works independently, but together they complete the entire shopping workflow. Easy trick to remember. Process is equal to independent worker doing a specific job in the system. It allows systems to perform multiple tasks efficiently and safely, making software more responsive and organized. Next important short question is 4. What is multiplicity? In object-oriented system development, multiplicity shows how many instances of one class can be associated with instances of another class. It defines the number of objects that can participate in a relationship. Simple meaning. Multiplicity tells us how many, like one-to-one, one-to-many, or many-to-many relationships between classes. Common types of multiplicity. 1 exactly 1. 0, 1, 0 or 1. 0 asterisk 0 or more. 1 asterisk 1 or more. Example. Consider a school system. Class student. A class can have 1 asterisk students, at least one student. Each student belongs to one class. Here, multiplicity helps us understand how many students can be in a class and ensures proper system design. Easy trick to remember. Multiplicity is equal to how many objects are involved in a relationship. It makes UML diagrams clear, precise, and easy to understand, especially when modeling real-world systems. Next important short question is 5. Describe the role of actor. In object-oriented system development, an actor represents a person, system, or external entity that interacts with the system. Actors are not part of the system itself but use or communicate with it to achieve some goal. Simple meaning. An actor is like a user of the system. It can be a human, another software, or hardware that sends inputs to or receives outputs from the system. Roles of an actor. 1. Initiates interactions, starts use cases or activities. 2. Receives outputs, gets results from the system. 3. Represents external viewpoint, shows how the system is used in the real world. 4. Defines responsibilities, helps in identifying what the system must do. Example. In an online shopping system, customer places orders, makes payments. Admin updates product details. Payment gateway processes payments. All these are actors interacting with the system but not part of it internally. Easy trick to remember. Actor is equal to external user or system that interacts with the software. Actors help in modeling real-world interactions and are essential for use case diagrams and understanding system requirements. Next Unit 2. Long questions. First important long question is 1. What is use case diagram? Explain the notations used in use case diagram. A use case diagram in object-oriented system development is a visual representation of the system's functionality from the user's perspective. It shows actors, users or external systems, and the use cases, tasks or services they perform, along with their relationships. Think of it like a storyboard for a movie. It shows who does what and how they interact with the system. Purpose of use case diagram. 1. Shows the functional requirements of a system clearly. 2. Helps developers and clients understand what the system should do. 3. Identifies the actors and their responsibilities. 4. Serves as a foundation for system design and testing. Notations used in use case diagram. 1. Actor. Represents a user or external system interacting with the system. Shown as a stick figure. Example, customer, admin, payment gateway. 2. Use case represents a function or service provided by the system, shown as an oval. Example, place order, make payment, generate report. 3. System boundary shows the scope of the system, represented as a rectangle surrounding use cases. 4. Association shows interaction between an actor and a use case, represented as a line connecting them. 5. Include relationship represents a use case that always happens as part of another use case, shown as a dashed arrow with. 6. Extend relationship represents optional or conditional behavior extending a use case, shown as a dashed arrow with. 7. Generalization shows inheritance between actors or use cases, shown as a solid line with a triangle arrowhead. Example, in an online shopping system, actors, customer, admin. Use cases, browse products, place order, make payment, update inventory. Relationships, customer, place order, make payment. Easy trick to remember. Use case diagram is equal to who, actor, does what, use case, in the system. It's simple, visual, and essential for understanding system requirements and designing software. Next important long question is: 2. Elaborate interaction diagrams with examples. Interaction diagrams in object-oriented system development are used to show how objects in a system communicate with each other to perform a specific task. They are part of behavioral modeling and focus on messages exchanged between objects over time. Think of them like a conversation map that shows who talks to whom and when. Purpose of interaction diagrams: 1. Show dynamic behavior of a system. 2. Help understand the sequence of messages between objects. 3. Aid in designing system interactions and workflow. 4. Useful for analyzing complex scenarios. Types of interaction diagrams. 1. Sequence diagram focuses on time-ordered sequence of messages between objects. Shows objects horizontally and time vertically. Example, in an online shopping system, when a customer places an order. Customer shopping cart, add item. Customer payment gateway, make payment. System customer, confirm order. 2. Communication diagram, collaboration diagram focuses on structural relationships between objects. Shows objects as nodes and messages as numbered arrows. Useful when emphasizing object links rather than timing. Example, same online shopping system. Customer communicates with cart, cart communicates with inventory, inventory confirms stock, cart communicates with payment gateway. Key components of interaction diagrams. Objects, actors, participants in the interaction. Messages, information sent between objects. Links, connections showing which objects can communicate. Lifelines, vertical dashed lines representing the lifespan of an object during interaction. Activation bars show when an object is active during processing. Easy trick to remember. Interaction diagram is equal to who talks to whom and in what order. Sequence diagram focuses on time order. Communication diagram focuses on relationships structure. Interaction diagrams make it easy to visualize object communication, understand system behavior, and design efficient workflows, making software development more organized and reliable. Next important long question is: 3. Write about events and signals in state machine. In object-oriented system development, state machines are used to model the behavior of objects based on different states and transitions between them. Two key concepts in state machines are events and signals, which trigger state changes. 1. Event. An event is something that happens at a point in time that may cause a state transition. Events can be external, from the environment, or internal, generated by the system. They are usually instantaneous and do not carry extra data. Example. In an online shopping system, clicking the Place Order button is an event. Current state, cart ready. Event, place order clicked. Next state, payment processing. 2. Signal. A signal is a message or notification sent to an object, which may trigger a state change. Signals can carry data and can be asynchronous, meaning the sender and receiver do not need to act at the same time. Signals are often used for communication between objects. Example. In the same online shopping system, payment gateway sends a payment success signal to the order object. Current state, payment processing. Signal received, payment success. Next state, order confirmed. Difference between event and signal. Feature, event, signal. Nature, something that occurs, message sent between objects. Data, usually no data can carry data. Timing, instantaneous, can be asynchronous. Example, button click, payment success message. Why events and signals are important. 1. They control the behavior of objects. 2. Allow dynamic response to system inputs. 3. Make state machine models realistic and closer to real-world scenarios. 4. Help in designing interactive and reactive systems like online shopping, ATM machines, or ticket booking systems. Easy trick to remember. Event is equal to something happens, triggers change. Signal is equal to message sent, triggers change. Events and signals are the heartbeat of state machines, allowing objects to react and move between states effectively. Next important long question is 4. Write about processes and threads in UML. In object-oriented system development, processes and threads are used in UML to model concurrent behavior in a system. They help in designing systems where multiple activities happen simultaneously. 1. Process. A process is an independent unit of execution in a system. It runs separately and can perform tasks without affecting other processes. Each process has its own memory and resources, like a separate worker in a factory. Example. In an online shopping system, order processing process handles orders. Payment process handles payments. Notification process sends email confirmations. Each process runs independently, but together they complete the workflow. 2. Thread. A thread is a lightweight subprocess that shares the same memory and resources with other threads in the same process. Threads allow parallel execution within a single process, making the system faster. Think of threads as multiple hands of a single worker doing different tasks simultaneously. Example. In the same online shopping system, the order process can have multiple threads. Thread 1, validate order. Thread 2, update inventory. Thread 3, send order confirmation. Key differences between processes and threads. Feature process thread. Memory on memory space shares memory with other threads. Overhead high-low. Independence fully independent dependent on parent process. Example payment process multiple threads validating payments. Why processes and threads are important in UML. 1. Model concurrent and parallel behavior of systems. 2. Help in performance optimization. 3. Show interaction between independent and dependent activities. 4. Useful in real-time systems like banking, online shopping, or ticket booking. Easy trick to remember. Process is equal to independent worker with own resources. Thread is equal to multiple hands of a worker sharing resources. By using processes and threads, UML helps developers design efficient, responsive, and realistic software systems that can handle multiple tasks at the same time. Next important long question is 5. Elaborate state chart diagram with example. A state chart diagram, also called state machine diagram, in object-oriented system development is used to show how an object changes its state in response to events. It focuses on the life cycle of an object, showing states, transitions, events, and actions. Think of it like a traffic signal system, where the signal changes color based on time or sensor events. Purpose of state chart diagram. 1. Model dynamic behavior, shows how an object reacts to events. 2. Understand object life cycle, tracks states from creation to termination. 3. Design reactive systems, helps in modeling systems that respond to external or internal events. 4. Improve clarity, visual representation makes complex behaviors easy to understand. Key components. 1. State, a condition or situation of an object at a specific time. Example, order placed, payment processing, order shipped. 2. Initial state, where the object starts, shown as a filled circle. 3. Final state, where the object ends its life cycle, shown as a filled circle with a border. 4. Transition, arrow showing change from one state to another. 5. Event, triggers a transition, example, payment successful. 6. Action, activity executed during a transition, example, send confirmation email. Example, online shopping system, order object. Initial state, order created. States. 1. Payment pending. 2. Payment completed. 3. Order shipped. 4. Order delivered. Transitions. Event, payment successful, move from payment pending, payment completed. Event, shipping started, payment completed, order shipped. Event, delivery done, order shipped, order delivered. Final state, order delivered. This diagram clearly shows how the order object moves through different stages in its life cycle depending on events. Easy trick to remember. State chart diagram is equal to life story of an object with events as triggers. It helps students and developers visualize object behavior, predict outcomes, and design reactive systems in a structured way, making software more reliable and maintainable.